Welcome back to the physics class, my dear students. So hope you all in the previous class gone through the concepts, basic concepts which was related to the motion in a plane chapter. Now I am just moving towards the second part of the motion in a plane chapter. So dear students, in the previous class I just discussed regarding the motion in a plane, that too especially the position vector. So dear students, let us see that how to write a position vector again. So my dear students, I am just showing you what is position vector. Suppose my dear students, assume that the particle is moving in a straight line. Then no problem to represent the position of a particle, so that easily we can represent that along the x-axis. Suppose if it is moving along y-axis, so easily we can say that the object is along y. Suppose if it is moving along a z-axis, easily we can say that the object is moving along z-axis. Then, if the same particle, if it is moving in a two-dimension, whether it may be xy, whether it may be yz, or whether it may be zx. So it means we have two different coordinate system. So then, how to represent the position of a particle? How to represent the direction of a particle? So then, my dear students, we should know the quantity that is said to be the position vector. See, this position vector is the one which exactly helps you to know the exact position of a particle at every instant of time. So at that particular instant, at this first second, what is the position of a particle in a plane? That is what it may be in the xy, or it may be in the yz, or it may be in the zx. But it should be in a plane, that is what two rectangular coordinate system are considered. So for our easy way of writing out the formula for the magnitude of the position of a particle, as well as to write the direction of a position of a particle in a plane, we use a quantity called as position vector. Then how to define this position vector? It is a vector which is drawn from the origin of the rectangular coordinate system. Rectangular coordinate system to the position of a particle at any instant. This was the definition of position vector. So then, how to write exactly this one with the help of graph? So, see dear students, that is what with the help of rectangular coordinate system. So, I am writing a rectangular coordinate system. Whereas here in this case, I am writing only the two axes. I am writing only the two axes. Why? Because we are discussing regarding the plane. Suppose if the object is moving in a space, we require three dimensions. That is what x, y and z. But this object is moving in a plane, no problem. That's why I am just using two coordinates, two axes. That is one x and y. Whereas O is said to be the origin of rectangular coordinate system. This is said to be the x-axis and this is said to be the y-axis. Dear students, you know that along x-axis the unit vector is I cap, and along y-axis the unit vector is j cap. What is this unit vector represents? The I cap and the j cap are the unit vectors which represents the direction in which the particle is moving. See, we said that position vector is a vector, good, from which point it is drawn? It is drawn from the origin of rectangular coordinate system. From where we should we should draw them from the origin of rectangular coordinate system. Good. Up to where we should draw it? To the position of particle at any instant. Suppose at the time t, if the particle is here, say the particle is represented by the letter P. If the particle is at this position inside the plane, if the particle is at this position inside the plane, then what is the position of a particle at this point? At this point, the position of a particle is written as x, y. Then what is position vector? It is a vector drawn from origin of coordinate, that is for rectangular coordinate system, to the position of a point P. Right. So that is what this OP is said to be the position vector, whereas this position vector is represented by the symbol R above the R and next to the arrow mark, because it is a vector quantity. It is having both direction as well as magnitude. This is how to represent the position vector for a particle which is moving in a plane inside the two rectangular coordinate system. Then how to represent that position vector now? See, my dear students, consider a particle which is moving in an xy plane at any instant. At some instant of time, the particle is at P with the coordinate axis x, y. Whereas O is said to be the origin, I and J are the unit vectors along x-axis and y-axis respectively. See, after writing the definition, write the diagram. After writing out the diagram, my dear students, so just note it down. Note it down. The words that I want repeated here in your notebook. So pause the video and write it. So matte dictate ಮಾಡಿ ಬರೆಯೋ ಅಂತಕ್ಕಂಥ time waste ಮಾಡೋದು ಬೇಡ. So 3 or 4 times ಆಗುತ್ತೆ. Rather than that, what I said, consider a particle which is moving in a plane. At some instant, the position of a particle is at P with a coordinate x, y. Right? Then O is said to be the origin of rectangular coordinate system, and I cap and J cap are the unit vectors along x-axis and y-axis respectively. Then the position vector is written as OP is equal to vector R. This is said to be the position vector. The lines ಬರೆದ ನಂತರ ಇದನ್ನು ಬರ್ಕೋಬೇಕು. One thing, dear students, last class in part 11 mention ಮಾಡಿ ನಾನು ಮೋಷನ್ ಪ್ಲೇನ್ ಅಂತ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದೆ. ಸೊ ಇಟ್ ಇಸ್ ಲೈಕ್ part 1. ನೆಕ್ಸ್ಟ್ ಹೊಸ ಚಾಪ್ಟರ್ ಅಲ್ಲ, ದಟ್ ಇಸ್ part 1, ಆ್ಯಂಡ್ ಈ ಮೋಷನ್ ಪ್ಲೇನ್ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ ಅದನ್ನು part 2 ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ವಿ. ಓಕೆ, ಹೋಪ್ ಯು ಗಾಟ್. ಸೊ ಒನ್ ಥಿಂಗ್, ನಿಮಗೆ ನೋಟ್ಸ್ ಅಂತ ಏನು ನಾವು ಕೊಡ್ತಿದ್ದೀವಿ. ಸೊ ಯು ಹ್ಯಾವ್ ದಟ್ ಮೆಟೀರಿಯಲ್ ಫಾರ್ ಯುವರ್ ರೆಫರೆನ್ಸ್. ಅಂದರೆ ಕಾಲೇಜ್ ಕಡೆಯಿಂದ ನಾವು ಒಂದು ನೋಟ್ಸ್ನ ಕೊಟ್ಟಿದ್ದೀವಿ. ಸೊ ಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಸಮ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ನ ಕೆಲವೊಂದು ಈಸಿಯಾಗಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಕೆಲವೊಂದು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ಡಿಫ್ರೆಂಟ್ ವೇನಲ್ಲೂ ಕೂಡ ನಾವು ನೋಟ್ಸಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ನೋಡಿ, ನಿಮಗೆ ಯಾವ್ದು ಈಸಿ ಅನಿಸುತ್ತೋ, ಅಂದರೆ ಅಡ್ವಾನ್ಸ್ ಆಗಿ ನೋಟ್ಸ್ ಸಿಕ್ಕಿದೆ ಅಂತ ನೋಟ್ಸ್ ಬರೀಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. ಸೊ ವಾಟ್ ಯು ಶುಡ್ ಡೂ, ಅಂದರೆ 2 or 3 ಮೆಂಬರ್ಸ್ ಡೌಟ್ಸ್ ಕೇಳಿದ್ದೀರಾ, ಯಾವ ಥರ ನೋಟ್ಸ್ ಬರೀಬೇಕು ಅಂದರೆ ಕ್ಲಾಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಬರ್ಕೊಂಡಿರ್ತೀವಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ನೋಟ್ಸ್, by that points note whether we should write the notes that what you given as a PDF ಎರಡೂ ಬರೀಬೇಕಂತ. ಎರಡೂ ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಎರಡೂ ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಯಾವುದನ್ನಾದ್ರೂ ಒಂದನ್ನು ಬರೀರಿ, ಅದು ನಿಮಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿರಬೇಕು. ಓಕೆನಾ? ವಿಡಿಯೋ ನೋಡ್ತಾ ಇರ್ತೀರ, ಇಲ್ಲಿ ನಾನು ಬರೀತಾ ಇರ್ತೀನಿ, ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಆ ಪಾಯಿಂಟ್ಸ್ ಈಸಿ ಅನಿಸ್ತು ಅಂದರೆ ಅದನ್ನೇ ಬರ್ಕೊಳ್ಳಿ. ಇಲ್ಲ ಮ್ಯಾಮ್, ನಾವು ವಿಡಿಯೋ ನೋಡ್ಕೊಂಡೇ ಬರ್ಕೊಂತ ಹೋಗ್ತೀವಿ, ಗುಡ್. ಇಲ್ಲ ಅಂದರೆ ನಿಮಗೆ ನೋಟ್ಸ್ ಅಂತ ಏನು ಪ್ರಿಂಟ್ ಕೊಟ್ಟಿದ್ದೀವಿ ನಾವು, ಸಪೋಸ್ ನಿಮ್ಗೆ ಅದರಲ್ಲಿ ಈಸಿ ಅನ್ನಿಸ್ತು ಅಂದರೆ ಗೋ ಥ್ರೂ ದ್ಯಾಟ್. ಓಕೆ, ಯು ಕ್ಯಾನ್ ಈವನ್ ರೈಟ್ ದ್ಯಾಟ್ PDF notes one, or you can write the thing that we are discussing on the board. ನಿಮಗೆ ಯಾವುದು ಈಸಿ ಅನಿಸುತ್ತೋ ಆ ಪಾಯಿಂಟ್ಸ್ನ ಬರ್ಕೊಂತ ಹೋಗಿ. ಸೊ ಏನಿರುತ್ತೆ, ವೇ ಆಫ್ explaining is different, that what we given in the PDF is different. ಸ್ವಲ್ಪ ಡಿಫ್ರೆನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ನಿಮಗೆ ಯಾವುದು ಈಸಿ ಅನಿಸುತ್ತೋ ಯಾವುದನ್ನು ಒಂದನ್ನು ರೆಫರ್ ಮಾಡಿ, ಎರಡನ್ನು ರೆಫರ್ ಮಾಡಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. ಓಕೆ, ಹೋಪ್ ಯು ಗಾಟ್ ದಿಸ್. ಕ್ಲಿಯರ್ ಇದೆ ಅನಿಸುತ್ತಾ? ಪಾಯಿಂಟ್ಸ್ ನೋಟ್ಸ್ ಬೇರೆ, ನೋಟ್ಸ್ ಬೇರೆ ಅಲ್ಲ. ನೋಟ್ಸ್ ಅಂದರೆ ಫಿಸಿಕ್ಸ್ಗೆ ಒಂದೇನೆ. ಸೊ ಇನ್ನು ನಾನು ಏನು ಮಾಡ್ತಿರ್ತೀವಿ ಅಂತ ಬರ್ಕೊತ ಹೋಗಿ, ಗುಡ್. ಇಲ್ಲ ನಿಮಗೆ ಇದಕ್ಕಿನ್ನ PDF ನೋಟ್ಸ್ ಈಸಿ ಅನ್ನಿಸ್ತದೆ, PDF ನೋಟ್ಸ್ನ ಬರೀರಿ. ಇಲ್ಲ PDF ನೋಟ್ಸ್ ನಮ್ಗೆ ಕಷ್ಟ ಆಗ್ತಿದೆ, ನೀವು ಮಾಡಿದ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಬರ್ತಂದ್ರೆ ಇದನ್ನು ಬರೀ. ಸೊ ಇಟ್ಸ್ ಲೆಫ್ಟ್ ಟು ಯು. ಸೊ ಯು ಕ್ಯಾನ್ ರೆಫರ್ ಎನಿ ಒನ್, ರೈಟ್? ಸೊ ಅದನ್ನು ಒಂದನ್ನು ಸ್ಟಿಕ್ ಆಗಿ ಎರಡನ್ನು ಸ್ಟಿಕ್ ಆಗಿ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ. Now I written the position vector as vector r. Then dear students, where position vector r is representing a position of particle p at the instant. However, this position vector is both having an I cap is what, which is having a unit vector along x-axis, as well as it is having a unit vector along y-axis. Then how to write this r? See, I am writing vector r can be written as x I cap plus y j cap. Sorry. So here vector r is represented in a plane. It means it is having both x-axis and it is also having y-axis. So then along x-axis, x is the magnitude, I is the direction, and along y-axis, y is the magnitude and j is the direction. So we combinedly represented r as x I cap plus y j cap. This is the representation of position vector in a rectangular coordinate system. How to write the magnitude of this r? Dear students, please be careful. This r vector, because you know in the previous class I just shown you that vector a can be written as magnitude of vector a into the unit vector a cap. This is the magnitude, a cap is the direction. So x is the magnitude, I cap is the direction. Similarly, this can be written as r magnitude of the vector r into r cap, that is the direction of the vector r, is equal to x I cap plus y j cap. Then what is the value of this magnitude? To calculate the value of this magnitude, I am using the mathematics. So you can observe that if I just extend this, so I will get a square, whereas this is a y-axis, this line is parallel to this, so I can represent here it as y. Similarly, this line is parallel to the x-axis, so I can represent it as x. Hope you got. Now I am using a mathematics here. So whereas theta is the angle which is present in between them. Now let's see. Let's write it down with the help of Pythagoras Theorem. So that how to write this? R square can be written as x square plus y square. This is x, right? So now r square can be written as x square plus y square. So this is said to be a triangle. This is said to be the triangle. I am going to name it as M and N. So OPM is a triangle. So that I can write it as OP square is equal to PM square plus OM square. So without writing that much of step, easily we can write it as the position vector r square is equal to y square plus x square. I am writing here. So I want to write the magnitude of r. So that the magnitude of position vector, the magnitude of position vector, so that r is equal to, so even you can represent it as the magnitude of r, otherwise you can simply write it as r, which is equal to, see from the triangle what I said, r square can be written as x square plus y square. Please be careful, I am not using I and j. Why? Because I am using only the magnitude here. I should not use the direction. I want to use only the magnitude. Then what is r? What is r? So apply square root on both the sides. Then r is equal to square root of x square plus y square. Yes. This is the magnitude of position vector and this is the equation of the representation of position vector. This is the expression for the position vector and this is the magnitude of position vector. Hope you got exactly that. What is a position vector? And what is the advantage of position vector? Dear students, so that the first point, that is what I am discussing, the advantage of position vector. So it gives the position of the particle in a coordinate system at any instant of time. A particle ಯಾವ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇದೆ, ಪ್ಲೇನ್ ಅಲ್ಲಿ ಅನ್ನೋದನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ಅಷ್ಟೇ ಅಲ್ಲ, it gives the direction of a particle, direction of a position of a particle which is moving inside the plane. So that is what ಏನು ಹೇಳುತ್ತಾ, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ ಆಗ್ತಿದೆ ಪ್ಲೇನ್ ಒಳಗಡೆ ಅನ್ನೋದನ್ನು ಕೂಡ ಹೇಳುತ್ತೆ. ಅಷ್ಟೇ ಅಲ್ಲ, even it gives the straight line which is going to join between the origin and the position of the particle at any instant. So these are the advantages of the position vector. So that we have 3 points. The first point is that, so it gives the position of a particle inside the plane, and the second point is it gives the direction of position of a particle which is moving inside the plane, and the third one is it gives a straight line which is joined between the origin and the position of the particle at any instant of time inside the plane. So this is about the position vector. Dear students, in the previous class we have done the addition of the vectors. So in the addition of vectors we did 2 methods of addition. One is triangular law of addition, and the second one is parallelogram law of vector addition. But now I want to add these vectors by using analytical methods. Now let us see the addition of vectors. Now let us see the addition of vectors by analytical method. So already we did the addition of vectors. So how we did that addition of vectors? Just by considering triangle law of vector addition as well as parallelogram law of vector addition, and we even written the statements and also the equations for both the addition methods. But now we are moving towards the different method of adding of the vectors, that is what? Analytical method. What is analytical method? So in analytical method we are just using a coordinate axis to just define the position of a vector, and also we are going to add. Assume, my dear students, we have the 2 vectors by the name A and by the name B. See, I am just going to write it down again. So this is the origin of a rectangular coordinate system. Whereas the rectangular coordinate system is having x-axis and y-axis. This is a motion in a plane. So I am just considering the 2 axis, that is only the 2 coordinate system I have, that is what is said to be the plane itself. Now, assume that we have the 2 vectors. We have the 2 vectors A and B. So this is said to be the vector A, and I am going to consider the another vector that is said to be vector B. So I have 2 different vectors. So vector A and vector B. Whereas vector A is a position vector of a particle which is moving in a xy plane, as well as B vector is also a position vector of a particle which is moving inside the xy plane at different instant of time. Dear students, along x-axis we have a direction, we have a unit vector, that is I cap, and along y-axis we have a direction that is said to be the unit vector j cap. And I draw the perpendicular to the x and y axis from the vector A and also from the vector B. This is about just the representation. Dear students, please be careful. I just written in a general form, but here this vector A is having both the components x and y, as well as the vector B is having both the components x and y. So that now I am not going to show the exact particular direction here. So because it is a general direction, a general representation of a direction, but now I want to write particularly for A and B. Dear students, vector A is in a plane. It means vector A is having both the position vector related to the x-axis and also y-axis. Whereas vector B is also having the components of x and also the components of y. So that I just drawn a perpendicular here. It means at this point, so that A vector is having an x component that can be written as Ax I cap. A is a vector, x is a component along x axis. So I can say that Ax is a component of vector A along which axis? X axis. And I indicates that the direction of the vector A. Similarly, now I just drawn perpendicular to the y axis. Whereas at this position, here I am writing it as Ayj cap. What it indicates? The vector A is having a component along the y axis called as Ay, and the vector A is moving along the direction of y axis with a unit vector j cap. Right. Similarly, I written here for B also, B vector. So B vector can be written as Bx I cap, where Bx is a component of the vector B along x axis and By is a component of the vector B along y axis. This is what just I represented. Then my dear students, let us note it down. What are these ones? A, B, Ax, Ay, I and J, right? So let us note all these things. See from the figure, vector A and vector B are two vectors. And Ax and Ay are the components of the vector A along x axis and y axis respectively. Otherwise, Ax and Bx are the components of the vector A and vector B along x axis. I am going to write where Ax, this should be written the next line, and Bx are the components of vector A along the x-axis. A vector and B vector along x-axis. Similarly, what are these values? Ay and By. So I am writing it. Ay and By are the components of vector A and vector B along which axis? Along y axis. Yes. Now, then what about this I and J? So here it is I, here it is J. I is a unit vector along x axis and J is a unit vector along y axis. So where I cap and J cap are the unit vectors along x and y axis respectively. Right. So these are all the given them. Then how to represent a vector A and how to represent a vector B separately. Then my dear students, we can express the vector A and the vector B with the help of the components Ax and Ay, Bx and By. Now let us represent it, my dear students. See, then how to represent this A vector can be written as, see, already in the position vector concept, I just shown you how to write R vector. I will write it here. So R vector can be written as x I cap plus y j cap, right? This is how to write. So in Manana we have two vectors. If we have only single vector, we can write in terms of x and y. But here we have two vectors. So for the two vectors also we have to write the x component and y component. Adike Ax, Ay, Bx, By separate ಮಾಡಿದೀವಿ. So A vector can be written as, so ಇಲ್ಲಿ x ಹತ್ರ ಏನು ಬರಿಬೇಕು? Ax along Ax is the magnitude of vector A along x-axis with the direction and unit vector I cap plus yj cap. What is the y component along the y-axis? So that is what ay into j cap. Similarly, then how to write b? So b can be easily written as bx I cap plus by j cap. Right. We just write on these two equations. Then my dear students, we have two vectors. See, we have added the two vectors by using two laws. One is triangle law of addition and another one is parallelogram law of vector addition. Then what is the resultant of a and b? What is the addition of a and b? So you know that already in case of triangular law of vector addition, you return the resultant vector capital R is equal to a plus b, and also you return that from the parallelogram law of vector addition that R resultant vector R is equal to a plus b. So then the resultant vector, how to write the resultant vector? Resultant vector is written as vector R is equal to, we are adding vector A and vector B, vector A plus vector B, right? Now, vector R is equal to, what is vector A? It is AX I cap plus AY j cap. Close the bracket. Now, let's write as it is. What is B vector? B vector can be written as BX I cap plus B1 j cap. Right. Now, let us separate this x component term first, and afterwards we can separate the y components. So now, R vector can be written as AX I cap plus BX I cap, right? Plus AY j cap plus BY j cap. Here I cap is common, so R can be written as AX plus BX into I cap, where AX and BX are the components of vector A and vector B along x-axis, plus here j is common, so AY plus BY into j cap. Right. So here AX plus BX into I cap plus AY plus BY into j cap. Finally, we got this expression, right, dear students? So rather than writing it in this way, even we can write it as R is equal to Rx I cap plus Ry j cap. Rather than writing it in this way, we have a formula here so that we can write x I cap y j cap. But to show it exactly in the help of analytical method, we finally prove that resultant vector R, that is an addition of two different vectors by the analytical method, can be written as Bx plus Bx I cap plus Ay plus By j cap. Suppose, my dear students, suppose if we have three vectors A, B and C, then what happens? Plus C here. I am just going to show you AX plus BX plus CX into I cap plus AY plus BY plus CY into j cap. If we have three vectors, rather than having three vectors, if we have three axes means here we have only considered a plane. Suppose if I consider a space, I will get three dimensions. It means x-axis, y-axis, z-axis. Along x-axis, I cap is a unit vector. Along y-axis, j cap is a unit vector. Along z-axis, k cap is a unit vector. Then for three dimension, how to write for three dimension? We use z component also. We are not showing it with the derivation. Simply we are writing the expression. So we are just using the z component also, right? So here ax plus bx I cap plus, this is for x component and this is for which one? Y component, and finally for the z component it can be written as az plus bz k cap. So for three dimension, the resultant vector of the two vectors in a space can be written as R is equal to ax plus bx I cap, AY plus BYJ cap plus AZ plus BZ K cap. So this is what how to derive or how to add the vectors by using analytical method. Okay, I'm just going to write it down. So next let us see even how to represent the magnitude of the vectors or the concurrent vectors, how to handle with the help of Pythagoras law of vector addition and all such things. So we can even reduce the expression for it. Okay dear students, now let us continue with the expression for the resultant of two concurrent vectors. So now I am just moving towards the derivation of the resultant vector of the two concurrent vectors. So my dear students, for the two concurrent vectors, even we calculated the resultant just by using this parallelogram law of vector addition. Simply we written it as R is equal to vector A plus vector B. But we should derive it in a very peculiar manner. So I am using two concurrent vectors. Let us say here I have the two concurrent vectors. Concurrent vectors are the vectors which are exactly originating from the same initial point. So I am just going to write it, my dear students. So this is a point A, which is said to be the initial originating point. So here we have a vector A. This is said to be the vector B. Resultant of these two vectors is represented by the letter vector R. My dear students, the angle between the two vectors, that is A and B, is taken as theta. And the direction of the resultant vector is considered as alpha. So, whereas this alpha is in between the resultant and this end of the vector, that is said to be A or B. Now, let us give a name AB. AB is a B vector. AC is a resultant vector. AD is a vector. Now, let us join these things. So, I am going to join. I am going to join BC and DC. Now, let us extend this AD. I am going to extend AD to point E. Then draw the perpendicular from C to AE. Right? This is said to be 90 degree now. Right? So then this is an angle theta. Why? Because if this is the angle between these two vectors, then this is also the angle between the two vectors which are extended. Right? So hope you got. I just took two concurrent vectors. Two concurrent vectors are the vectors which are having the same initial point. Said it is A. Whereas vector A is given represented by AD and vector B is represented by AB. And the resultant vector is represented by AC. And now theta is the angle between vector A and vector B, and alpha is the direction of resultant vector. Now I am going to extend the vector A so that to meet E, and after that I am going to draw the perpendicular from C to AE. So finally I got an angle theta according to the mathematics, so that if this angle is theta, then this angle should also be equal to theta. So dear students, take down the points after this, because if I write all those things, the board will be well and I cannot do for the derivation. Just take down the points. So AD is vector A. So just write it down. So AD is vector A. Otherwise I will write it better and other things. AD is equal to vector A and AB is equal to vector B. Right? And acting along are the vectors acting at the same point, which is the same point A. Yes. Next, AC is the resultant vector R, is the resultant vector which is having the same initial point A. Idu kuda initial point agide same A ide. Then what is theta? Theta is the angle between vector A and vector B. Now extend AD to meet 2E to point E, right? Then draw perpendicular from C to reach point E. Yes. These are all the things that we explained now. It's to now explain nicely. Then now let us move on, right? See, now we should calculate the magnitude of the resultant vector R, and also even we should calculate the direction of the vector R. To calculate that, we have the parallelogram A, B, C, D. So where A, B, C, D is a parallelogram. So rather than using that, so we have another one triangle. So I am just noting it down. A, C and E. We have the triangle A, C and E. For finding magnitude of magnitude, we should calculate the magnitude now. So we should calculate the direction of R also. First let us calculate the magnitude. So the calculate magnitude, we have the triangle ACE. So from the triangle ACE, we are applying Pythagoras Theorem. AC square is equal to C square plus AE square. So I am repeating again, AC square is equal to CE square plus AE square. CE square plus AE square. Dear students, here we don't know, we know what is AC because AC is R, and we don't know what is the value of CE, but also we don't know the value of AE. So AE can be written as AD plus DE. AD plus DE. I am writing here AC square. This can be written as vector R square is equal to, now CE we don't know, so keep CE as it is. CE square plus what is DE? AD plus DE. So I am writing it as AD plus DE whole square. So in place of AE I written it as AD plus DE whole square. This is the form of A plus B whole square. It can be written as A square plus B square plus 2AB. So R square is equal to AD square plus DE square plus 2 into AD into DE. Right? So A square plus B square plus 2AB plus CE square. Now, what is AD? AD is vector A. What is DE? We don't know the value of DE. Please keep DE as it is. Substitute the value of AD. See. AD is vector A plus. What is DE? Don't know. Keep as it is. Plus 2A. So, just I am writing out the magnitude here. So magnitude of the no need to represent the arrow mark. So I am just writing out R. So now here what is DE? We don't know the value of DE. Write DE as it is plus CE square. So we got this equation. Take it as equation number 1. Now we should calculate the value of DE and also we should calculate the value of CE. To calculate these two values, I am using another one triangle, that is DCE. Right? From the triangle DCE. See, by using Pythagoras Theorem, DC square can be written as DE square plus CE square. See, I am writing it again. So by using Pythagoras Theorem, so DC square can be written as CE plus DE. CE square plus DE square. See, I should write DE in terms of DC or CE in terms of DE, because one thing I should eliminate from the equation. Another one thing that I can calculate the term and I can substitute. So at least I should eliminate one of the term from that. To eliminate that, see now I am going to write whether I want to write DE or whether I want to write CE. No problem. You can write any of the things. That is, you can write in terms of DE or CE. So I am going to write DE now. DE square is equal to DC square. So it becomes to this side means minus CE square. Right. Take it as equation number 2. Now I want to calculate still the value of EC and also DE. Then what the thing that I want to do? So yes, from the same triangle I am using trigonometry, sin theta and cos theta. How to write sin theta? Sin theta means opposite by hypotenuse. Opposite is CE, hypotenuse is DC. See, CE by DC. Opposite by hypotenuse. Then similarly, how to write cos theta? It is adjacent by hypotenuse. Adjacent is DE, hypotenuse is DC. So that is DE by DC. Then what is CE? Because I want DE and also CE, right? So I got almost all the values here. So now CE is equal to DC into sin theta. Cross multiplication ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇಲ್ಲೂ ಕೂಡ cross multiplication ಮಾಡಿಕೊಂಡ್ರೆ DE is equal to DC cos theta. Right. ನನಗೆ I got the value of DE and also CE. Let us substitute that in the equation. So take it as equation number 3. Put equation 3. See, just by replacing the terms you can calculate, because you know the value of DC. DC ಅಂತ ಗೊತ್ತಿಲ್ಲ, because DC is parallel to AB. ಹಾಗಾದ್ರೆ DC ಮತ್ತು AB parallel ಅಂದ್ರೆ AD B vector ಆದರೆ DC ಕೂಡ ಏನಾಗಬೇಕು? It should also be B vector. It should also be B vector. So now I am going to write it. So put equation 3 in equation 1. So put equation 3 in equation 1. It will happen. Observe ಮಾಡಿ. R is equal to A square plus what is DE square? DE square is DC square cos square theta plus 2A into DE. DE is DC cos theta plus C square. What is C square? DC sin theta. See my dear students, I just substituted the equation 3 in equation 1 and I got it in this way. Then here in this case you can observe it very carefully. You know the value of this, which one? DC. So what is DC here? DC is B. So let us substitute that. R is equal to A square plus DC is B. So B square cos square theta plus 2A. DC is B cos theta plus DC. DC is B sin theta. B sin theta. Right. Okay. This much we just did. This much we just written it here. Then now let us see. R is equal to. You know that here the terms that what I written here, it can be represented in the form of A. So in that equation we have left out with the sin theta, whereas it is not going to give you the clear explanation regarding the magnitude. So my dear students, rather than directly doing this, because I am showing you the two values, so even you can replace this D square with the equation number 2. Put equation 2 and 3 in 1. So what is D square from equation 2? It is DC square minus CE square plus 2A DE, sorry, DC DE plus CE square. Yes, ಇಲ್ಲಿ ಅದನ್ನ ಬರೀತಾ ಇದ್ದೀನಿ. minus C square plus C square ಅಂತ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. So here ಏನು R is equal to observe my A square plus BC square under B square plus 2A. D ನ ಏನಂತ ಬರೀತೀರಾ? D can be written as DC cos theta. Right. So now R is equal to A square plus B square. Not R. It is R square. It is R square. R square carry ಆಗಬೇಕು. So here it is 2A. What is DC? It is B into cos theta. Observe carefully. A square plus B square plus 2AB cos theta. I want only R. I don't want R square. So squaring or applying square root on both the sides will get square root of A square plus B square plus 2AB cos theta. This is the required expression for the magnitude of the resultant vector R for the two concurrent vectors. Hope you got this, my dear students. Still we should calculate the angle. So let us calculate it in the next class. Thank you, my dear students.